All right, in this video, we're going to talk about 7G, and we're going to talk about how to build truth tables, not just for individual compound statements or even to compare pairs of statements, but we're going to use truth tables to evaluate arguments. So here's how you set them up. Again, the left-hand side is going to include the truth values for each of the simple statements, just like always, follow the same schematism. And then you're going to have a column for each of the premises and then the conclusion, just like this. So, and then you fill out the truth table in the usual ways for each of those compound statements. So, it's going to look like this. You're going to follow the order of operations as always, and they've highlighted here the truth values of the main operators. Now, how do we use the truth table to evaluate the validity of an argument? Well, here's how you do it. You're going to look for lines on the truth table where all the premises are true, but where the conclusion is false. Let me say that again. You are going to look at each line of the truth table and look for lines where the main operator for each of the premises is true, but where the conclusion is false. Now, if there are any such lines, one or more of them, then that argument is not valid. But if there are no lines where the premises are true and the conclusion is false, then that argument is valid. So, look at this one. Let's look at line 1. Now, the first premise here is false. And right now, right then, I know already that line is not going to give me a counterexample to validity. It's not going to disprove the validity of the argument. You know why? Because to be a counterexample to the validity of the argument, all the premises have to be true and the conclusion false. So if I see that one of the premises is false, it's like, I know that that one doesn't disprove validity. And with the validity of an argument, when you're using the truth table, assume like the argument is valid until proven guilty. So still innocent on line 1. What about line 2? True premise 1, true premise 2. So this is a possible counterexample to validity, and there's a false conclusion. Alarm bells should go off. That shows right there that this argument is not valid. Now, let's look at the other lines as well. True premise, false premise. So that's not going to disprove anything. True premise, false premise. So that doesn't disprove anything either. But this line 2 here gives you a true, true, false. And when that happens, do not pass go, do not collect $200. The argument is not valid, because a valid argument is one where if the premises are true, the conclusion must be true. Now, arguments can also tell us that either or both sufficient or necessary conditions exist. If you eat your ice cream, if you eat your spinach, then you get your ice cream. And you get ice cream only if you eat your spinach. That's a triple bar. So you can use truth tables to determine that. Now, let me say something about technical validity. Technical validity exists in 3 cases. When the conclusion is a tautology. Now, think about it. What's a tautology? A tautology is a statement that is always true. There's only true truth values underneath the main operator. So, of course, if the conclusion is a tautology, then the conclusion will never be false. And if the conclusion is never false, then there's not going to be any lines on that truth table where the premises are all true and the conclusion is false. It's bulletproof against that. So here, let me give you an example. Let me give you an example of a tautology. A tautology would be either P or not P. For example, either I'm in South Carolina or I'm not, right? That's going to be true no matter what, always. So I could say the moon is made out of green cheese. You know, King Louis XIV is the president of the United States. And therefore, conclusion, I'm either in South Carolina or I'm not. And guess what? That's a valid argument, technically. You know why? Because there's no case in which the premises will all be true and the conclusion false. The conclusion will never be false. It's always true. I know it's weird. That's why they call it technical validity. It's like, that argument is crazy. How could that be logically valid? But it is, because the conclusion is always true. Number two, the other form of technical validity, when one of the premises is a self-contradiction. Now think about it. This is like the flip side of what we just said. If one of the premises is a self-contradiction, it's always going to be false, right? So if I say, I am in South Carolina and I'm not in South Carolina, those can't be true. Like that statement can't be true because those can't both be true at the same time. It's self-contradictory. So if that's a premise of the argument, then there's never going to be a case where all the premises are true and the conclusion is false. So the argument will be valid. For example, if I say, I am in South Carolina and I'm not in South Carolina, Biden is president of the United States, therefore Greenville is the capital of South Carolina. Guess what? That argument is valid, technically valid. You know why? Because one of the premises is a self-contradiction. There's going to be no case in which all the premises are true and the conclusion is false. Number three, when the premises are contradictory, that's like another similar case. If they're contradictory, then they can never all be true, right? So if I say premise one, I'm in South Carolina. Premise two, I'm not in South Carolina. Conclusion, therefore, Neil Armstrong was the emperor of China. That argument is valid because there's no case where all the premises are true and the conclusion is false, because there's no case where all the premises are true because the premises are contradictory. Okay. Although these arguments are technically valid, they're stupid. To put it in more precise language, they're like the first kind is trivial because the conclusion is going to be uninformative. The conclusion, you can know that's true without even looking at the premises. And the second, two, and three, they're going to be unsound because at least one premise is going to be false. So they're going to be bad arguments. The point is that logically, they will technically be valid. Now, truth tables can also show us that certain argument forms are valid or invalid. Like you can use a truth table to prove modus ponens and modus tollens. And it will show you that always works. Let's do an example here. Here's how. So we've got two premises and a conclusion. That backslash says what comes next is the conclusion. So premise one, either not R or S. Premise two, not S. Therefore, conclusion, not R. So we're going to set up this truth table, right? And here's each of the main operators of each of the premises and the conclusion. So what are we looking for? We're going to assume the argument's valid, and then we're going to look for counterexamples to validity. What's a counterexample? That's a line on the truth table where the main operators of all the premises are true, but the conclusion turns out false. All right, so let's look at line one. True premise, false premise. So still innocent. Line two, false premise, so that's not a disproof. Line three, true premise, false premise, so therefore that's not a disproof of validity. Line four, true premise, true premise. If there's a false conclusion, game over, but the conclusion is true. So you know what we know now? This argument is valid. There's no line on the truth table where both premises are false. I'm sorry, where both premises are true and where the conclusion turns out false. Let's do another example. This is a word problem. if the government helped with student loan debt, then students would not try to get good jobs. The government is not helping with student loan debt. I guess that's why students don't try to get good jobs. Now, the first thing you have to do with the word problem is to formalize it. And so they've done that, and then we can set up the truth table. So you can see what G and J stand for. Now, let's look for validity, right? Look at line 3. Here's a line where you've got a true premise. The other premise is also true, but the conclusion is false. And that shows that this is not a valid argument. So that's how you do that.